Everyone, and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here is question 1. In the diagram below, triangle Brie is the image of triangle Joe after a translation. So I'm just going to put these in order. Brie is the image of Joe after a translation. So that means, so here's Joe. So this is like the first triangle, and then we're translating it up to Brie. So I'm just labeling them 1 to 2 because we're going this way, translating. And then triangle cat is the image of triangle Brie after a line reflection. So then we're going, so this is our last triangle, we're going this way after a reflection. So now we could easily see how like each point is related. So notice we go from point O to R, J to B, and E to I. And then this is reflected, so I to T, R to A, and B to C. So now let's look at the answer choices. Which statement is always true? Angle R is congruent to angle T. So no, right? Because we're doing reflections, so really I would correspond to angle T, right? We're like folding this in half down this imaginary line. So I goes to T, R goes to A, and B goes to C. So no, this is not our answer. Choice number 2, it says angle J is congruent to angle A. So let's see, so if we're translating up, J would go to B and then B would go to C. So no, not our answer. Choice number 3, JE over here is congruent to RI over here. So this is translating, so JE would be congruent to BI. So no, that's not our answer. So by process of elimination, our answer has to be choice number 4, but let's look at why. OE is congruent to AT. So OE is over here. We translate it up and it becomes RI, and then we reflect it and it becomes AT. So these are all equal to each other. So yeah, that's our answer, choice number 4. Question number 2. A right cylinder is cut parallel to its base. The shape of this cross section is what? So let's get a cylinder. So we have a cylinder and its base is down here. And if we were to just kind of cut and take out a piece of the base and lay it flat, it would look something like that, which is a circle, choice 2. Question number 3. What is the minimum number of degrees that a regular hexagon must rotate about its center to carry onto itself? So a hexagon has 6 sides. Looks something like that. We want to make sure we're dividing this evenly. So if it has 6 sides, 1, 2, 3, 4, 5, 6. And so the interior angles of any polygon is going to be 360 degrees. So 360 degrees divided by 6 sides is going to be 60, which is choice 3. Question number 4. In the diagram below, a sphere is inscribed inside a cube. The cube has edge lengths of 18. What is the volume of the sphere in terms of pi? So volume of a sphere is equal to 4/3 pi r cubed. So here we just need to fill in this formula, 4/3 pi, and then the radius, we know that this whole length is 18. So the radius is going to be half of that, which is just going to be 9 cubed. And we could just plug this into our calculator. And here they said they wanted it in terms of pi, so we could just leave it like that, 972 pi. Choice number 3. Question number 5. In the diagram below, EM intersects HA, so here's EM, here's HA, at J. EA is perpendicular to HA, so we can put a little right angle there, and EM is perpendicular to HM. Put another right angle there. If EA equals 7.2, EJ equals 9, AJ is 5.4, and HM is 3.29. What is the length of MJ? So we're looking for this over here to the nearest hundredth. So right away when we see that there's perpendicular lines intersecting, and then we know that these two triangles are going to be similar. So they're going to be similar to each other by angle, because we have these this vertical angles here. Angle EJE is going to be congruent to angle HJM, and then they both have a right angle. So we know that triangle EAJ is going to be similar to triangle HMJ by angle. So what this tells us is that we can actually make a proportion out of the lengths they give us to find the missing value here that we want to find, this XJM. So to do that, we just need to be cognizant of the proportions and the right direction that these triangles are. So I'm gonna redraw them actually and make sure they're all facing the same direction. So we have this one. I'll do this little one first, HMJ. They're sharing that angle J, and HM is 3.29, and then we're trying to find X. And now let's draw this bigger triangle. So I'm just redrawing them so that it's easier to look at how to set up the proportion. So this is angle A. And now we can set up a proportion. So we have 3.29 over X, so just this side length over the base is equal to the bigger triangle side length over its base, 5.4. And we could cross multiply. And if you look back, they wanted it to the nearest hundredth. So this is going to be 2.47, which is choice number 1. Question number 6. Which equation represents the line that passes through the point 2, -7 and is perpendicular to the line whose equation is y equals 3/4 x plus 4? So if we want the point 2, -7, so if you look, it's going to be in point slope form. So we have this point that we definitely want those coordinate points in there. And then we also have, we want to be perpendicular to this equation here. So if we want to be perpendicular, we're going to be focusing on the slope. And to make something perpendicular, we're just going to flip and negate. So 3/4 is now going to become -4/3 to be perpendicular. So we know we're going to have our slope equal to -4/3 for this new equation. So if you look at our answer choices, notice that it's in point slope form. So let's just write out the formula for that. So now we could just fill this in. So our y is going to be y minus y1, which is -7, but this is going to become a +7. And then this is going to equal to the slope, which we found is -4/3 because we flipped and negated what they gave us. So it can be perpendicular, times x minus our x value, which is 2. So we have y plus 7 is equal to -4/3 times x minus 2, which is choice number 3. Question number 7. In triangle RHM below, angle R is equal to 110 degrees and angle M is equal to 40 degrees. Triangle RHM is reflected over side HM to form quadrilateral RHR prime M. Which statement is always true? The first thing I'm going to want to do is just find this missing angle over here, knowing that the interior angles of a triangle add up to 180. So if we do 110 plus 40 and then subtract that from 180, we'll get 30 degrees. So I'm just going to fill that in first. And then we can deal with the reflection next. So it says this triangle is reflected over side HM. So here's HM. So I'm just going to do a little sketch of what that might look like. So point R would maybe be around here. And we get R prime. It would look something like that. And because we reflected, all the angles are going to remain the same. So this is going to be 110 degrees, this will be 30 degrees, and this will be 40 degrees. Now let's see what might be true when we look at this. So in choice number 1, it says quadrilateral RHR prime M is a parallelogram. So just looking at this, I know I sketched it, but already it doesn't look like the opposite sides are parallel. If you look at RM and HR prime, these don't look parallel. But another way you could tell that is that the opposite sides are not equal to each other. Over here, 40 plus 40, this side is 80 degrees. And then over here we have 30 plus 30, 60 degrees. And in a parallelogram, they have to be equal to each other. opposite angles are congruent. So no, choice 1 is not our answer. Angle MHR prime is 40 degrees. So no, you could see here that it's actually 30 degrees, MHR prime. So no, this is 30 degrees. Angle HMR prime is 40 degrees. Yeah, HMR prime. So we're over here. This is 40 degrees. So that's going to be our answer. So let's just look at the last one to make sure we're correct. MR is congruent to HR prime. So no, you could see HR prime is 30 degrees and 110 degrees on this side, and then this side it's 40 degrees and 110 degrees. So they're not equal to each other, different angle values. So choice 3 is our answer. Question number 8. The funnel shown below can be used to decorate cookies with melted chocolate. The funnel can be modeled by a cone whose radius is 6 centimeters and height is 13 centimeters. The baker uses 2 cubic centimeters of chocolate to decorate each cookie. When the funnel is completely filled, what is the maximum number of cookies that can be decorated with the melted chocolate? So what we're going to do here is find the volume of this cone and then divide by 2 cubic centimeters to see how much it can be filled. So let's find the volume of the cone, which the formula for that is just pi r squared h 1 times 1/3. And this is going to be equal. So now we just fill this in so that we know that the radius is 6 centimeters, so 6 squared, times the height, 13, and then all times 1/3. So we plug this into our calculator. Let's see what we get. So we get this big number, 490.088454. And we're going to do with that is divide it all by 2, because that's how much is used to decorate this cookie, how much chocolate is used to decorate this cookie. So all this number divided by 2, which gives us 245.044227. And if you look at our answers, they wanted it to the nearest centimeter. So this is just going to be 245, which is choice number 2. Question number 9. In circle O below, two chords CT and BN intersect at point A. Chords CB and NT are drawn. Which statement is always true? The thing about inscribed angles of intercepted arcs is that the angles are equal to each other. So this, if you look at this arc CN, notice that this angle CBN is intercepting this arc, and so is this angle NTC over here. So these angles are going to be equal to each other. And another thing about these two triangles, if you look at triangle CBA and triangle NAT, is that notice they have a vertical angle that's also equal to each other, this CAB and NAT. So by vertical angles, these are equal, and by inscribed angles intercepting the same arc, these two angles are equal. So we can say that triangle CBA is similar to triangle NAT by angle. And because of that, we know we can use proportion relationships for the sides. So if we just look at this first one, it says NT over here over TA is equal to CB over BA. So that looks right to me. So I'm going to circle that. But let's go through each answer choice to make sure this is correct. So here we have angle BAC is congruent to angle TATN. So no, that's not correct, right? BAC is over here and ATN is over here. So those angles are not congruent. 3, we have another proportion. Let's see how that is. NA over AB. So this side to this side of the other triangle is equal to TA, the base, over AC. So no, because these don't line up. This NA would correspond to CA, not AB. So no, that's not our answer. And our last one, BCA. Okay, so we're up here. Is congruent to NTA down here. So no, C is not congruent to T. So our choice here is choice number 1. Question number 10. In the diagram below of triangle ABC, CBF is drawn. AB bisects angle FBD. So let's just mark this so AB over here bisects angle FBD. So that means this angle is going to be congruent to this angle. And BD is perpendicular to AC. So BD is over here, perpendicular to AC, so we're going to have two right angles here. If angle C is 42 degrees, what is angle A? So we're looking for this angle over here. Would they give us this? So it's not the only thing they give us, so we know we can figure out what the angle is over here, because you know that this is a 90-degree angle and we have 42, so we can add these up, 90 plus 42, and then subtract that from 180, and we'll get 48 degrees over here. So over here, notice this is a straight line CBF, which they said line CBF, so that means this entire thing is going to add up to 180 degrees. So we know that 180 degrees minus 48 is 132, and we know that these two angles are going to add up to 132. And we also know that they're equal to each other because AB is a angle bisector of this angle, FBD. So we could just divide 132 by 2 because we know they're going to have to be equal to each other. So 132 divided by 2 is 66. So you know that this angle is 66 degrees and this angle is 66 degrees. And now we can figure out A based on this. We have this triangle ABD. So we have 180 minus 66 plus 90. So we know angle A is going to have to be 24 degrees, which is choice number 1. Question 11. Encircle O below, OA is equal to 6, COA is 100 degrees. What is the area of the shaded sector? So we're looking to find the area of this shaded region. So we're going to do that by using the formula for area of a sector of a circle. So it's just like finding the area of a circle, pi r squared, but now instead of just pi r squared, we're going to kind of divide out the number of degrees we're looking for divided by the whole circle, 360 degrees. So if we have pi, our radius is 6 squared, and then the degrees we're looking for is the shaded region. We know this is 100, so we know to get the shaded region, it's just going to be 360 minus 100, this angle here. And we'll get 260, so this shaded region angle is 260 times, so that we'll just fill that in 260 divided by 360. And they want this in terms of pi, which is even easier. So we have 36 times 260 divided by 360, which just gives us 26 pi. Choice number 2. Question number 12. In rectangle ABCD, diagonal AC is drawn. So I'm just going to start sketching this out. It says AC is a diagonal. Is drawn. The measure of angle ACD is 37 degrees. And the length of BC is 7.6 centimeters. What is the length of AC? So if you look at this, we have right triangles, and we can solve this unknown length by using SOHCAHTOA. We have right triangles, so the first thing I'm going to do is, so one of the things about rectangles is that they have opposite parallel sides, and this diagonal AC can be treated like a transversal. So knowing that, we can take 37 degrees and place it over here. So angle BAC is going to be equal to angle DCA based on alternate interior angles. We're trying to find this value, and we know that this is 37 degrees. So if you looked, we're looking in terms of this angle, we have the opposite value, and we're looking for the hypotenuse value. So we have the opposite and the hypotenuse, which is going to be sine. So we have sine of 37 degrees, just the angle we're working with, is going to be equal to the opposite, 7.6, over the hypotenuse, which is what we're trying to find. And then we could just do a little trig and algebra to solve this. Just cross multiplying. We get x is equal to 12.628. If you look, they wanted it to the nearest tenth of a centimeter. So this is going to be 12.6, which is choice number 4. Question 13. A peanut butter manufacturer would like to use a cylindrical jar with a volume of 1180 centimeters cubed. The jar has a height of 10 centimeters. What is the diameter of the jar to the nearest tenth of a centimeter? So we're working with a cylindrical jar. So let's draw out a cylinder. The volume of the cylinder in this case is equal to 1180 centimeters cubed. The jar has a height of 10 centimeters. What is the diameter of the jar? So we're looking for this length. What is the diameter? So just a little reminder of what volume of a cylinder is. It's equal to pi r squared times h. So in this case, we are given what the volume is. We're also given its height, and we need to find the diameter. But we first need to find the radius. We have 1180, we know is the volume. Pi is just a constant. R squared we're going to need to find, and then the height is 10. So let's just solve this like normal. So we get this number 37.56056657 is equal to r squared. So to find r, we're just going to take the square root of both sides. And we get r is equal to 6.1286. So the tricky thing here is this is the radius, but what they're asking for us for is for the diameter. So what we're going to do is take this radius and multiply it times 2 to get the diameter. So we're going to get 12.257. And if you look, they wanted it to the nearest tenth of a centimeter, which is 12.3, which is choice 4. Question 14. Triangle KLM is dilated by a scale factor of 3 to map onto triangle DRS. Which statement is not always true? So the first thing I'm going to want to do is just sketch out these two triangles, what they might look like. I made these two right triangles so they're easy to work with, and imagine KLM, DRS, and notice that each corresponding letter is in the right place. So KLM, DRS. So we want to make sure that that holds true when we're looking at these answer choices. Let's go through each answer choice and see what makes sense. So for choice number 1, it says angle K is congruent to angle D. So notice these two are right angles. So we're looking for something that's not always true. So this is actually true, which is why it's not going to be our answer. The next one, choice 2, says KM is 1/3 of DS. So you can see that KM corresponds to DS, and really just saying it's 1/3 of DS is really just the reverse of the dilation, because we're dilating by a factor of 3. So the original is 1/3 of the new one, which is 3 times as bigger. So yeah, that is true, which is why it's not our answer. Choice number 3, the area of triangle DRS is 3 times the area of triangle KLM. So this is actually going to be our answer because area does not transfer exactly the way perimeter does. So because the next answer is the perimeter of DRS is 3 times the perimeter of KLM. And if you forget which one is which, you can actually just plug in some numbers and see that this is true. So I'm gonna do that. So if we have, let's say this is a 3, 4, 5 right triangle, and we're dilating by a scale factor of 3, we're gonna multiply each of these lengths by 3. So 5 times 3 would be 15, 3 times 3 is 9, and 3 times 4 is 12. So if we find the perimeter and the area of each of these triangles, and then look at the scale factor, you'll see that area does not translate here. So first, the perimeter, we're just adding up 4 plus 5 plus 3 on this triangle, and we'll get 12. And over here we're adding 12 plus 15 plus 9, which is going to give us 36. Now if we divide 36 divided by 12, you'll see that the scale factor here is 3, which is correct, which is what we were given, scale factor of 3. So that's why choice 4 is not our answer. And now let's just look at the area of each of these triangles. So if we do 1/2 base times height, it's 1/2 3 times 4. So this will give us 6. And over here, this is going to give us 54. And if you take 54 and divide it by 6, you'll see that the scale factor here for the area is actually 9. So that's why area does not work for dilation, but for perimeter it does. So that's why choice 3 is our answer here. Question 15. A rectangle with dimensions of 4 feet by 7 feet. So let me just draw this out. So we have a rectangle 4 feet by 7 feet. We're continuously rotating it about one of its 4-foot sides. Resulting 3-dimensional object is what? So we're taking this rectangle and rotating about one of its sides. So let's pretend this is a line here, and we're going to be rotating it about this line, this rectangle. So it would be coming to this side, and then this side would also be 7 feet long and 4 feet tall. But we would be continuously rotating it, so it wouldn't just be over there, it'd be like over here, over here. So it'd have like all these little slices. So if it was continuously rotated like this, you can imagine that this would look like kind of like a short fat cylinder like this, where the diameter is 14 feet long and the height is the same, 4 feet long. So now that we have like a picture of this shape, let's look at the answer choices. Cylinder with a height of 7 feet, no, it has a height of 4 feet. Cylinder with a height of 4 feet and a base radius of 7 feet. That's going to be our answer because the radius is going to be equal to 7 because the diameter is 14 feet. So choice number 2 is our answer here. Question 16. In right triangle ABC, altitude CD is drawn to hypotenuse AB. If AD equals 4 and CD equals 8, the length of BD is what? So let's start drawing out these triangles here. So we have a right triangle ABC with altitude CD is drawn to hypotenuse AB. So the hypotenuse is AB, and then we have CD as an altitude. And now we're given some more information. AD equals equal to 4, CD is equal to 8, and we want to know the length of BD over here. So this is one of those problems where there's 3 different triangles and they're all similar to each other. So I'm going to draw out the triangles first. So I'm going to keep them all the same direction. So first we have this bigger triangle ABC. And notice we have this length 4 plus x. And then we have these 2 other smaller triangles. So here's the smallest triangle. So let's draw that. But I'm going to kind of flip it around to make sure it's in the same format as this. So we have the right angle up here, and then we have the shorter leg and then the longer leg. So we have the shorter leg, so D is where the right angle is. Then we have the shorter leg, A, which AD is 4, and then we have C. And now let's do this medium-sized triangle with the same idea, where the right angle D is up top, and then we're going to have the shorter leg DC equals 8, and then we have DB, which is X. Okay, so we're looking for DB, right? We're looking for this value. So if we look at the 3 different triangles, the thing about all these triangles is that they are all similar to each other by angle. So we could set up all these different proportions. Oh, I forgot to put 8 over here. DC. DC is 8. Okay, so knowing this, we can find out x easily by using these two triangles. The two smaller triangles. And then we could just set up a proportion. So we have 4 over 8 is equal to 8 over x. And then we could just cross multiply. I feel like these are easy questions, but they're hard to visualize, which I feel like is the main problem with these kinds of questions. So I do have a video that goes over a bunch of different examples step by step, so please check that out. So our answer here in this case is choice number 4, 16. Question 17. If ABCD is a parallelogram, which additional information is sufficient to prove that ABCD is a rectangle? So first I'm going to draw a parallelogram. And to label it ABCD, just make sure to label this starting in the lower left hand corner and then going clockwise. So going around this way, ABCD. I'm also going to draw a rectangle just so we know what we're trying to prove, ABCD with the same structure. Okay, so now let's go through each answer choice and see what makes sense here. Choice 1 says AB is congruent to BC. We know that all sides are not congruent in a rectangle. So this would be for a rhombus, because these are next to each other. These are consecutive sides, so no. AB is parallel to CD. So you could see that this is true for all parallelograms, not just rectangles. So this wouldn't be the answer because this isn't anything special. AC, so now we're doing diagonals. AC is congruent to BD. So is that true? Would that tell us it's a rectangle? So actually, yes, this is going to be our answer because rectangles have congruent diagonals. And then the last one, just to make sure we're right, AC is perpendicular to BD. So those are the diagonals saying they're perpendicular to each other. This again is a rhombus. True for a rhombus property, but not true for a rectangle. So this is not our answer. Question 18. Slide segment APB has endpoints -5, 4 and 7, -4. What are the coordinates of P if AP to PB is in the ratio 1 to 3? So these kinds of questions come up and they're really nice because they have a nice, easy formula to remember. So as long as you remember the formula, you should be good for these kinds of questions. So we have -5, 4. I'm going to label it x1, y1. And then B7, -4. I'll name x2, y2. And then we have this ratio 1 to 3, which I'll label AB. So the formula for this is just going to be, there's going to be an x value and a y value. So for x, we have x1 plus a over a plus b times x2 minus x1. And now we just got to plug this in. So we have x1 is -5 plus a is 1 over a plus b, 1 plus 3 times x2, 7 minus x1, which will just be plus 5. This is going to be -2. Then for y, we're going to do the same thing. y1 plus a over a plus b times y2 minus y1. And then we're going to plug everything in. So y1 is 4 plus a, which is 1 over a plus b, 1 plus 3 times y2, -4 minus y1, which is 4. Plug this into your calculator and you'll get 2. So our answer here is -2, 2 as a coordinate point where the x is -2 and the y is 2. So this is choice number 1. Question 19. In the diagram below, AB and CD intersect at 8, and CA and DB are drawn. If CA is parallel to BD, so I'm just going to draw that in parallel law, which statement is always true? So there's a couple of things we can see with these two triangles. So notice we have this vertical angle, they're intersecting here, so we know these two angles are going to be congruent to each other. And then because these lines are parallel and they're being cut by a transversal, we know that they're going to have a couple of equal interior angles happening. So we have this alternate interior angle. So we have this angle A, this angle B, and then we also have the angle D to the angle C. These angles are all equal. So we know that these two triangles are similar by angle. So triangle ACE is similar to triangle BDE by angle. And we found that by vertical angles and then parallel lines cut by transversal. Okay, so now we could look at the statements and see which makes sense. AE is congruent to BE, no. CA is congruent to DB, no. Triangle AEC is similar to BED, yeah, that's going to be our answer. And then our last one saying that they're congruent, which they're not congruent triangles. And just a reminder on the difference between the two. For congruent triangles versus similar triangles. For congruent triangles, it would have to be proven by side, angle, side, angle, side, angle, angle, side, or hypotenuse, leg. And for similar triangles, it's angle, angle, side, side, or side, angle, side. So that's the difference, and that's what we need to know here. And that's our answer, choice number 3. Question 20. If sine of 3x plus 9 is equal to cosine of 5x minus 7, what is the value of x? So the great thing about this question is that sine and cosine are complementary cofunctions, meaning that their angle values are going to add to 90 degrees. So we could just take the angle values in here and set them equal to 90 degrees. And I'll just write y up here. Sine and cosine are and then we could just solve this as normal. So we get that x is equal to 11, which is choice number 2. Question 21. Which set of integers could represent the lengths of the sides of an isosceles triangle? So for this question, we're going to need to remember the triangle inequality theorem. So what this states is that the sum of any two sides of a triangle must be greater than the third side. You could remember this as A plus B must be greater than C. So we know in an isosceles triangle that two sides are going to be equal to each other. And if you look at the answer choices, they already have that, right? We have 2 1s, we got 2 2s, 2 3s, and 2 4s, two of the same kind. So that's why we're going to need this triangle inequality theorem. Is going to come in handy for us for this question. So if you add 1 plus 1, is that greater than 3? That's what we're going to be asking ourselves for each of these questions. So that 2 is 2 greater than 3? It's not, so that's not true. So 1 is not our answer. 2 plus 2, is that greater than 5? 4 greater than 5? No, not true. 3 plus 3, is that greater than 6? Is 6 greater than 6? No. So that's not our answer. And finally, by process of elimination, choice number 4 is our answer, but let's see why. 4 plus 4, is that greater than 7? And yes, it is. 8 is greater than 7. So that's our answer. Question 22. We have another one of these altitude questions. In the diagram shown below, altitude CD, I'm just going to draw a right angle here, is drawn to the hypotenuse of right triangle ABC. Which equation can always be used to find the length of AC? So we're trying to find AC, so I'm just going to label it X. And then we have all these different proportions that it could possibly be. So the first thing I'm going to want to do is just draw out the triangles again, like we did in the last question. So I'm going to draw out the big triangle, ACB, and we're trying to find AC. And then I could see that we're going to be, since we're trying to find AC, I'm just going to focus on this triangle and draw that out. So C, we have the right angle, So I'm going to take this triangle and flip it and rotate it so it's in the same order as this bigger triangle. So we have the long side here, so we're gonna need to flip this. So this is D up here, and then our longer side is gonna be AD. So we wanna keep that consistent. So we have AD again, and then down here will be AC, and here will be X. So notice these two triangles share the value AC. Since they share these two sides, we're gonna wanna input different values for AB and AD. So I'm just gonna call them, I'm just gonna make up Y and Z for them. Okay, so now, so you could see that to get this proportion, we would do something like AC over AD is equal to AB over AC. So something like that, right? Okay, so now let's look at our answer choices though and see what makes sense, because they might not have exactly this answer that we just made. So let's see, AC over CD. So already we could see that AC is over here and CD is on the right. It's the shorter side. So this is not going to be our answer. CD, okay, we're starting over here, over AC. Okay, same problem. That's not going to be our answer. Choice number 3, we have AC over CD. Okay, yeah, we can see that's not going to be our answer again. They all have like some form of this, so we can clearly see that's not going to be it. And choice number 4, by process of elimination, it has to be this one, but let's make sure this makes sense. So this has AB over AC, so that's the base of this triangle over the base of this triangle. That looks good. We're setting this equal to AC over here, the longer side that we're trying to find, over AD, the longer side of the other triangle. So yes, that's our answer, and this makes sense. Question 23. Which congruent statement is sufficient to prove parallelogram mark is a rhombus? So let's start off by drawing a rhombus, and remember we always want to start in that lower left-hand corner when labeling shapes that they didn't give us. So start over here and then go clockwise. So is mark a rhombus? So let's look at this first choice. MA is congruent to MK. So that actually would prove it's a rhombus right away, because these are sides that are next to each other, which wouldn't happen in a parallelogram, right? Because a regular parallelogram looks something like this, and consecutive sides are not equal to each other, congruent to each other. So choice 1 is our answer, but let's go through the others and make sure this is right. MA is congruent to KR. So that's nothing special, because this is for normal parallelograms where opposite sides are congruent to each other, MA to KR. So that's not our answer. Angle K is congruent to A. Also for normal parallelograms, opposite angles are congruent, opposite interior angles are congruent, so that's not our answer. And then angle R is congruent to angle A. So this is not a property of a rhombus to have consecutive congruent angles. So this would be for like a rectangle or a square. So that's also not our answer. So our choice here is choice number 1. Question 24. A line whose equation is y equals negative 2x plus 3 is dilated by a scale factor of 4, centered at 0, 3. Which equation represents the image of the line after the dilation? So typically with a question like this, we would dilate the y-intercept only and then leave the slope alone. But in this case, since the dilation is centered at 0, 3, right, it tells us that. Notice where this is, the y-intercept is. So like if we graph this out, so if we go to 0, 3, which is the center it's going to be dilated at, and then, but look at this y-intercept, it's also at 3. The dilation is centered at 0, 3, a point that is on the line, which happens to be the y-intercept itself. This line is going to remain unchanged. So if we dilated this, it would look exactly the same. So it's going to be the same value, which is negative 2x plus 3, which is choice 1. So that's our answer. So I'm just going to write out So that's our answer. This is the last question for part 1. Look out for part 2 coming out soon. Good luck and happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!